We know that measuring speed and velocity needs complex math and calculations. What if I told you that there is another way to measure them? Graphs are an easy way to visualize motion. To measure motion, we need to observe the time taken by the object to complete that motion. The passing time is plotted on the horizontal part of the graph called the x-axis. The position is marked on the vertical part of the graph called y-axis. Now, let us closely study the movement of this ant and mark its motion on our graph. Imagine a sweet kept on the book. The ant starts moving towards it. When the ant moves forward, the motion of the ant is plotted on the map as the position of the ant keeps changing. When the ant comes to a stop, the line on the graph becomes a straight line parallel to the time axis. Now, move the sweet away from the ant. The ant starts moving again towards the sweet. If the ant continues its motion after staying still, the change in its position is marked on the graph. Now, if the ant moves back to its original position along with the sweet, the line drops down to 0 on the position axis of the graph. As the ant reaches its final position, the line touches 0 on the position axis. Notice the path taken by the ant. Even though the ant has taken a curved line, the graph is drawn using straight lines. This is because the motion of an ant is plotted against time on a graph with no direction being considered. Distance is the full length covered by a moving object from one point to another. Here, the ant moves from point A to B. So, the distance covered by the ant is the length of the path it took to reach point B from point A. Displacement, on the other hand, is the shortest distance between the initial position of the object and its final position. Here, the displacement of the ant is from point A to point B in a straight line, which is the shortest distance between the points. Graphs can be used to show the distance covered by an object. Here, the total distance covered by the ant can be measured as the total distance it has traveled, which is also given by the position line marked. Graphs can also be used to show displacement made by an object in motion. Since the ant has moved back to its original position, the total displacement made by the ant is 0 because there is no difference between its initial starting position and final position. So, any object that has no movements will be shown on a graph as a straight line parallel to the time axis. If the line on the graph is a slanted line, the object is said to be in constant motion. If the line is very steep, then the object is said to be moving really fast. If the object comes to a stop after moving, the slanted line would become a straight line parallel to the time axis. If the object keeps moving and comes to a standstill again, the graph will look like this. Now, if the object returns to its original position, the graph will show a line going down to position 0. By looking at the slope of a line on graphs, we can know the speed of an object. If the line has a very steep slope, it means that the object is moving really fast. If the line on the graph is a diagonal straight line, the object is moving in a constant speed. If the line on the graph has less slope as shown, then the object is moving slowly. Thanks for learning with us. See you next time.